Okay, we are continuing to solve problems with variables on both sides. And now we're going to look at a real life situation. All right, so the question says, a boat leaves New Orleans and travels upstream on the Mississippi River for 4 hours. The return trip takes only 2.8 hours because the boat travels 3 miles per hour faster downstream due to the current. How far does the boat travel upstream? Okay, so the first thing we have to do is understand the problem. So to understand the problem, we have to realize that we're looking for how far does the boat travel. So that's a distance. So your distance formula, distance equals rate times time. So that's something that we can remember. So distance equals rate times time. We also know that the boat goes upstream for 4 hours, and the return trip takes 2.8, but the boat travels 3 miles per hour faster downstream. But we know that they're going to travel the same distance, okay? So the boat's going to go so far upstream and so far downstream. So we don't know how far that is, but we do know how long it takes. So we can do x times the time. So that would be the rate. We don't know yet. All right, so going upstream on the river, it takes 4 hours. All right, so we can say x times 4. All right, on the return trip, it only takes 2.8 hours, okay? 2.8 hours because the boat travels 3 miles per hour faster. So we know that the boat's going to travel 3 miles per hour faster, but the time it takes is 2.8 hours. So it takes less time. All right, so what we did was set up the distance upstream, and we set that equal to the distance downstream, okay? And then we can solve and see what that is. So let's go ahead and start working this out. So if we want to do distributive property first, so we're going to do, we can go ahead and bring this down, 4x, 4 times x is 4x, and then 2.8 times x is 2.8x, and then 3 times 2.8 is 8.4. All right, and then again, as you know, I like to keep my variable positive when I can. So I'm going to subtract 2.8 from both sides. The reason I'm doing that is because I have a variable on both sides, and I have to isolate the variable on one side in order to solve. So 4 minus 2.8 is 1.2x, and that equals 8.4. To solve for x, I have to divide by that 1.2. So 8.4 divided by 1.2 is 7. All right, so if x is 7, we can now figure out how far the boat travels, okay? So rate times time. We know it took 4 hours. We just solved for rate. So 4 times 7 is 28 miles, okay? So we do 7 times 4. That was traveling upstream, and that equals 28 miles. And it should be the same distance coming downstream. So let's do 7 plus 3 times 2.8. 7 plus 3 is 10 times 2.8. 10 times a number, just going to move the decimal place over. So that one equals 28 miles as well. So you can see that that worked on both sides of the equation. So the boat travels 7 miles per hour upstream, okay? And then you can determine that that is a total of 28 miles for the distance, okay? So it says, how far does the boat travel? How far does the boat travel? The boat travels 28 miles upstream. And then it turns around and comes back downstream as well. But the question says, how far does the boat travel upstream? So to answer the question, that would be the way to answer the question. All right, I hope this helps. And again, it says to solve and check. So we did check to make sure that that equaled 28 miles on both sides of the original equation. And then we made sure that we answered the question that it was asked as well. So hope this helps. Modeling real life equations. Okay, so here's a similar problem. It says self-assessment. So this is one that you should try to work out on your own. So pause the video, take a few minutes, see if you can solve this problem, very similar to the last one, and then come back to see if you got the correct answer. All right, so this one says a boat travels upstream on the Missouri River for 3.5 hours. The return trip only takes 2.5 hours because the boat travels 2 miles per hour faster downstream due to the current. How far does this boat travel downstream? All right, so we know that the boat travels upstream for 3.5 hours. So we can say X times 3.5 hours. And then the return trip only takes 2.5 hours because the boat travels 2 miles per hour faster. So it's going to go 2 miles per hour faster, and it's going to take 2.5 hours. All right, so let's see what we have. So we have 3.5x all right, and that is going to equal 2.5x using distributive property, and then 2 times 2.5 is 5. And then again, we have a variable on both sides, so to solve, we're going to subtract 2.5x from both sides. 3.5 minus 2.5 is just 1x, so x equals 5. So we need to know how far the boat traveled. Remember, distance equals rate times time. We knew the time was 3.5, and now we know the rate is 5. So we can say 5 times 3.5. All right, so 5 times 3.5. And that's going to be 17.5 miles. All right. Now, remember x times 3.5, this was the boat traveled upstream. This time it says, how far does the boat travel downstream? If you remember, we set upstream equal to downstream. So that means this should be the same amount. So let's check it. So we're going to do x. X is 5, remember. So 5 plus 2, and then times 2.5. All right, so that's going to be 7. 5 plus 2 is 7 times 2.5. 7 times 2.5, 17.5. All right, so how far does the boat travel downstream? So the boat travels 17.5 miles downstream. All right, that's it for this problem. If you have any questions, let me know.